Hello, everyone, and welcome to today's webinar. My name is Rhonda Seelinger, and I am the Customer Engagement Manager for iClicker, and I want to thank you so much for joining us today. We really do appreciate your time. We are going to get started here in just a moment. I do have a couple of quick announcements first. As you probably just heard, everyone is in listen-only mode, and we do this just to help keep out background noise. But that doesn't mean that we don't want to hear from you, because we definitely do, and we hope to make this as interactive as possible. To communicate with us, you can either use the chat area or the questions area. I do monitor both of those throughout the presentation, and we promise to do our best to get to everybody's questions and address any comments that you have. You can do that throughout any time in the presentation, and we will address them as soon as we see them. Also, I do want to let you know that we are recording today's webinar. We frequently get asked that question, so I did want to let you know we are recording it. And we archive all of our webinars on the iClicker.com website, so you're welcome to check that out to see any of our past or future webinars. And with those couple things covered, I am very pleased to introduce our guest speaker today, Matt Evans of the University of Wisconsin-Eau Claire. Matt?
Hello, thank you, Rhonda. So hopefully today I can show you some of the tips and tricks that I've learned over the years using clickers. So one of the things is I've actually been using clickers since 2004 and have really taken a lot of these ideas from both my own classroom and from a lot of the different people who've come ahead of me. So one of the things that as we're going through this, you can always type into that chat window, ask some questions. But one of the first things is just wondering if you could type in whether you are a novice or an experienced user in clickers, so I just kind of can see where we are with everyone. So just to start off, one of the things that I look at is we want to engage these really large classrooms. And so when we look out into our classrooms, oftentimes we ask, all right, who has the answer to this? And a couple of people raise their hands. And one of the things we're doing is we're trying to get the student to engage in the material. And so when I look at my class, this is for those of you who've seen this before, say this is my class, and I'm looking out over my class, and I say, what do you like to eat? And, Zana the zebra says, I like to eat twigs and bark. And Casey the cow says, I love grass. I love to put grass in all of my stomachs. And Pablo the panda says, I love to eat bamboo. And so one of the things that happens when you take this is you look out over your class and you make some sort of assumption based on what you've heard from those who've responded. So if that was my response, I could have had I could think, well, maybe they're all herbivores, right? And one of the things that happens is you've only really listened to those vocal students. And of course, you look out over your class, and Allie the alligator is slowly eating a steak sandwich in front of everyone. So maybe you make another assumption where all the black and white animals are herbivores. And of course, even then, sometimes you're not really gauging everyone from the class. And so you really want to get everyone's opinion as you're asking these questions. So one of the things that we know about using clickers is that it promotes higher class attendance and participation. And there's a bunch of studies that have shown that iClicker improves these attendance statistics, and it gets more students to come to class. It gets them off their Facebook pages and gets them away from texting, and it really allows them to join in that discussion and that lecture. So one of the things that we find is that that students in a class that uses clickers quite often are oftentimes actually disappointed if they don't if that class doesn't have a clicker question that day, because they start to see that as a really important part. Now, one of the things that I look at is when I looked over this class, these are the people who answered. And when you look at the entire class, what you can see is that not everyone has actually replied. So when I started off this webinar, I asked, all right, what's your level? And I only got a couple of people to respond. And so there's only a few people, that vocal people who want to participate. And so what we're trying to do with an iClicker is say that we want 100% participation throughout the class, and we value everybody's response. And we're going to use that response in order to help the student learn. Now, a couple of other things that I was thinking about over the last week, thinking about this webinar, is that I actually just read an article on the New York Times website that says, "Do men think they're better at science than women do?" And it's actually true. The study that came out, it was in biology, but it said that males on average predicted that they were smarter than 66% of the class, whereas women were much closer to that 50%, where they predicted they were smarter than, say, 54%. So men had this idea that they were smarter than most of the class. And when the male students were paired against others, specific people in the class, they were 3 times more likely to say that they were smarter than that classmate that they were working with. And so what this says is that there's still problems, even if you have a classroom that has, say, a majority of women in it, in a science classroom. Oftentimes what happens is they don't see their voice as being as important. And so there's some studies out there that show that having a voice and being able to really reinforce the understanding of material, especially for females, is beneficial. And it doesn't hurt the males, but instead lifts those females up to be more confident in what they're doing. So a lot of the ideas behind why we want to have that all-class participation goes back to really helping the student learn the material. Now, none of this is new, really. These 2 books that came out in the 90s, so they're 20 years old, Just-in-Time Teaching and Peer Instruction, really laid the foundation for a teaching style that I have continually evolved with, which is get the students to do more of the work in real time so that they can gauge where they are, so they can move beyond things they don't understand. So one of the things I always think about is I don't use technology just for the sake of using technology. I try to use it in ways that allow me to bring things to the classroom that maybe the students don't understand. Maybe it allows me to do things both more efficiently and more quickly. And some of the things that I can do with clickers, I can't do in a traditional lecture. So to start off, I think about the traditional lecture on the left versus the lecture that I try to promote on the right. When you look at the two, on the left, it's people are all sort of engaged in that sage on the stage, the person in front sort of spewing out all of the information. Everyone else is taking it in, versus the one on the right. I have students who are writing things down. They're writing down the questions that were on the board. I have a group talking to one another. So in these 2 scenarios, I'm really looking for the one on the right, where the students are helping themselves get to the right answer. The other thing to note is that even in small classes, if you look on the right, there's somebody reading the newspaper. And so it's not always smaller is better, because people can still be disengaged if they're not given that chance to participate. A couple of other just studies just to sort of motivate us to make sure that we understand how well the clickers can work. This is a study that was done where 3 questions were asked. Question 1 asked everyone to answer by themselves. And when that was done, 52% of the students had it correct. The same question was asked again, and after what you look at is 52% had it correct initially, but then we lost 5% after the peer instruction. So a few people actually dropped off. And then of the incorrect, almost half of those people actually got it correct after peer instruction. Then that last question, the new question, question 2, there was no other instruction being given, but the number of correct responses then went up to 73%. So within just asking questions and having students talk to each other, the percentage of correct answers went from 52 to 73%. Now, sometimes students will push back on this and say, well, why should I teach other people? But we all know that one of the higher level understandings is to be able to help somebody else understand what's going on. And so I make sure that I bring this up to my students, that the peer discussion is helping both people, the person who doesn't understand and the person who understands it, get to that higher level of understanding. So let's start with one of the questions that I've used. In this case, when you climb up a rope, the first thing you do is pull down on the rope. How do you manage to go up the rope by doing that? This is one of these questions that, depending on the level of your student, it's difficult to understand what's going on. And one of the things is, how long do you even wait to have that question answered? And if you were to do this in a traditional classroom, within 5 seconds, somebody would be giving the right answer away, and it would be before some people had even finished understanding the question. And so this is one of the things that I did a study about 10, 12 years ago on wait time. And one of the greatest things that a clicker system can do, besides having everyone answer, is force you to wait to make sure that everyone is getting the question and understanding it. So in this case, the timing of how long you wait really looks at, the number of responses. In this case, 11 seconds has gone by, no one's answered yet. I listen for the noise in the room as it sort of comes to a crescendo and starts to tail off. I know that they're coming to an end. And so having the question up on the board, monitoring how long it takes them to get to an understanding, can come from both that the noise level in the room and the number of responses that you're getting. One of the effective things to always do is say 15 seconds. I shout that out, and they know that they have to have something in by that time. That does allow those who are lagging behind to at least make their best attempt, because they want to feel like they're part of that classroom. Now, the next thing I always do, which is really important, is have that final feedback of what is the correct answer. I'm visually showing that with the big red circle, and also having some sort of explanation here. And in this case, it's Newton's third law. You pull on the rope pulls back on you. And if you're thinking about that free body diagram of the person, the two forces are the gravity going down and the force of the rope pulling up on that person. If they were just hanging there, those would be exactly the same. If they're pulling themselves up, there's that slight increase in the force going up that causes them to be able to move upward. So let's look at another example. Say that you've been lecturing on probability for a little bit. And one of the things you can do is, I've just talked about probability. They're going to be great at this. I'm just going to ask them a question. So in this case, it's resetting that student attention. So, students they think that sitting through a 15-minute class sometimes is excruciating. And what happens is, if I stop I'd like to stop every 5 minutes and let them do something, because I get tired of my own voice. In fact, I think I'm tired of my own voice already today. So what I do is I put in this think, pair, share. And what that does is, even with those big bold letters, think, pair, share, the think is answer that for yourself, then turn to your neighbor, see what they got, and then come back to a consensus and revote if you need to. So in one of these, this question, probabilities, you flip two pennies, which result is the most common. I know from asking this question enough times that the most probable answer is D, where all are equally likely. But what they forget to do is they forget to apply, the rules of probability in that if the first one comes up in one way and the second one is 50-50, that the heads and tails is actually going to be the most common outcome. And so once again, it's the ability to have students come to the correct realization to the answer rather than you just telling them through this think, pair, share. Now, a couple of other things to think about is what are the questions that you have in your class that you know students are not going to get correct on that first try? And I've been teaching long enough to know where these things come from. And one of the ones is acceleration. And so what I want them to know is they can get to the right answer rather than me just asking a question and then saying, all right, here's the answer. Why didn't you get it right? I want them to come to the correct answer themselves. Now, I'm sorry to kind of show something like this because it does take time to understand how your classes go, especially in the format of asking questions and having them come to the right answer. But this is something that I've refined over the years. So I throw a ball up in the air, and it's very top. What is it? It's acceleration. So when I give some multiple choice answers here. And one of the things that I found is they just weren't getting this right, especially in our conceptual physics class. And so the big power of having some sort of student response system, and in this case, iClicker, is I can figure out what to do next in real time. I don't have to show the results to the students if I don't want to. So on the right-hand side, there's a base unit that some people use that shows the answers that are coming in. There's also an app on a phone where you can actually look at the answers coming in so that the students don't see the number of responses in real time. What happens then is if I wanted to, I could say show the results. And if I was to show the results, maybe two of the answers look like they might be probable. And by leaving the poll open with the results up, you can actually watch in real time as they talk to each other and change it. And you can actually get them to go down the rabbit hole in the wrong direction by showing a result where a majority of the people have it wrong. Then without even thinking, they will go to that. And if you do something like that early in the semester, they think twice about doing that later in the semester. They think, well, what did I get wrong to make it so that is the correct answer? So if you trick them enough times, they will start to get smart. Now, this is a little bit scary for, say, new teachers because you prepare everything. You think this is the perfect lecture. But at this time, I have the ability to say, all right, the most common wrong answer is, say, B or whatever that is. Or I could do that 50-50 like they do in Who Wants to Be a Millionaire. Or I can just say, we're not getting it, talk to your neighbor. Especially if they haven't had that really deep conversation, or you could just ask a different question. So this allows you the idea that you can see how they're answering a question in real time without them seeing those results really helps you figure out what to do next. So if I review that question, what's the acceleration at the very top? I'm not going to ask the same question. I'm going to ask a different one. So if a car is at rest and has an acceleration of 0 meters per second squared, how fast is it moving 1 second later? And this one is hopefully quite straightforward to those of you who are on this. But what you see is if the acceleration is 0 meters per second squared, how fast it's moving after 1 second is, in this case, B, 0 meters per second. What I did was I threw in an analysis of units to make sure that they understood the difference between velocity and acceleration units. But the fact is that if it's not accelerating and it starts at 0, it's never going to be moving. Okay, so that helps them. And then I ask another question where we're looking at what the velocity is at the very top. And in the original picture, it basically said v is equal to 0. I covered that up. And so you would hope at this point that they would pick 0 for the velocity. And then, as you can see, I'm highlighting the tricky part here, where I highlighted the velocity. So when I go back to the original question, maybe I'll have taken away some of the wrong answers. In this case, it's almost always 0 and negative 9.8 meters per second squared for that acceleration in that original question. But now when I get back to this, they see that, well, you hope that they see that if the acceleration and the velocity are 0 at the top, that it would never move again, and that the acceleration at the top has to be that negative 9.8 meters per second squared. So this is a way for them to think through why the acceleration cannot be 0 at the top when you throw a ball up, and then it's the velocity that's 0. So this is just an example of looking at how students have struggled in the past and then making up something that allows them to get to the right answer. Now, all of these ideas came from me sketching things on the board in real time or talking through it with students, listening to how they explained why they thought it was wrong. And so that's one of those things that we do as educators that's very important, is to understand why they're coming to the wrong conclusion and then trying to move beyond that. A couple of things
Hey, Matt.
Yeah.
Sorry to interrupt you. Just have a question. So when you're doing the Think, Pair, Share together, is there sort of a time frame that you give the students to work together? Can you kind of tell when it's ready to move on? Or do you time that part too?
I time nothing. So the way that I always do my my Think, Pair, Shares is I listen, I walk around the room, and I look to see how people are reacting. If I start hearing things about parties, obviously it's time to come back. So it's not a time thing. I did a question, I remember this once very vividly, where it was about where you would see a rainbow if the sun was, where would the rainbow appear if the sun was in mid-afternoon. And it was one of these things, it took 15 minutes of starting and stopping the same question and going over the material again for them to get to it. But it was because they were missing a lot of the points. They weren't being able to put it together. So when I think about how long I take, it's always noise level in the room. You don't have to listen to every conversation, but if I have a room of 150, I just breeze out in to kind of go up one of the aisles. I kind of hear what's going on. I see the number of responses coming in. And when it gets to be about, 75 to 80%, I know that I'm ready to tell them that 15 seconds, give them that time to finish it, and then allow them to move on. So it's really something that you can kind of gauge based on how you perceive them getting the answer. And sometimes you just give up and give them the right answer and then ask it the next day. So hopefully that answered the question. All right, so a couple of things to note is that you really do need to make these challenging. If you make them too easy, they just kind of zone out. And the main thing is if they're all getting it without having to talk to each other, then it's not really effective. So I kind of look for questions where a half to 2/3 get it correct, so that they can both explain it and become higher level learners, or that the people who are not getting it have somebody that can explain it to them. And of course, I always bring that back to the quote expert in the front of the room, that expert opinion on how to think through that problem. And so it is my, sort of, I'm the last person to come around and help them with it. And that's one of the things that they start to really look for, is that helping each other as they go through. Now, I have a couple of other types of questions with the iClicker Reef, which is the online version. You can actually have something called a target question. So in this case, click on the graph where the velocity is 0. And, you give them the graph, velocity versus time graph. I've already said too much, of course, because normally I just put this up and have them start clicking. And one of the things I do with this one is, if you think about it, where are they going to get this wrong? And of course, what you can see is they're getting it wrong in a way that they're maybe not sensing that it's velocity that you're asking. Maybe they're doing the wrong graph. They're thinking of distance versus time and looking at that as the graph that they're doing. So in real time, I might have my chalkboard. I actually still have chalk. I might draw this distance versus time and think, what does a distance versus time tell us? And kind of go through that in front of the room and then say, remember, this is not distance, this is velocity. And hopefully what that would do is it would bring them back to the fact that velocity is 0 on this graph only in that lower left-hand corner. And in this case, the acceleration is 0, where a majority of people had it wrong. And so it's one of those things where knowing where they're going to make these mistakes, you tease that out a little bit. And by them engaging, it piques their interest in the question. And if they get it wrong, they're much more likely to try to work to get it right if they're doing peer instruction than if you just tell them that answer. So there's a lot of different things that you can do with this polling. You can actually do these pre-readings. So if I have a reading, I might have 2 or 3 questions right at the beginning of class that they that allows them to know that was important. It challenges them to think. It breaks up the class. I actually give them 90% just for clicking the button and another 10% to get it right. It's very low stakes, but that 10% is enough to get them motivated to try to learn a little bit better. Also, with the physical clickers, if I kept, in my syllabus, I say if you have 2 clickers, everyone loses all their points for the semester. And with the online or the iClicker Reef, there's actually you can actually pick where your classroom is, and they have to be within 100 feet of that classroom, up to 500 feet. You can choose that, and they can be marked present. But if they're in their dorm room, they can't be getting online and actually answering questions. So it really does help that attendance. So this is that instant feedback to the professor or the instructor really helps the students because they feel like they're integrated into that learning experience. Other things that you can do with the iClicker is quizzing. So I might have this as one of my initial questions coming in. So you have this force acting at some angle described in the question, and there's 3 questions that they're answering. And with quizzing, you can actually have 3 questions that they answer without starting and stopping the quiz, and you can actually see those answers as they come through. A couple of things to note here is I'm really looking at, do they understand the question? Because once they can draw this, they should easily be able to get the answers without using any calculator. Because if a force is acting not along one of the axes, it has to be less than 100. And in this case, it's going to be 98 in one direction and 17 in the other. And if it's 10% or 10 degrees below the negative x-axis, then your x value is going to be that negative 17 newtons in the x direction. And a majority of the force is going to be in the negative y direction, so that's going to be negative 98 newtons in the y direction, and that's known as the third quadrant. So right there with these 3 questions, I can really understand how they're doing on the basic setup of angles before we get into a lot of that sine and cosine stuff. And so this quizzing is a way to have them answer multiple questions, and some people actually do all their quizzing grading in real time using this quizzing module from iClicker. So, and that can actually be done. Yes, go on.
My apologies. Sorry. I was just going to ask if you grade quizzing differently than like the normal participation kind of stuff and polling.
Yes, I do, because I call it, quote, higher stakes. So it's like in a few things that I do, I say, this is all about you, and you're going to do this alone. And so I'm clear about those. And I don't do that as nearly as much, mostly because I don't want them to push back against the clicker in a certain way, but I do want to have those times when they are just doing something themselves, so I can really evaluate how they're doing without having that peer instruction. I have some colleagues who love this, where they go Monday. They have a 3-day-a-week class where Monday, Wednesday is clickers, free for all, one question at a time, all the peer instruction you want. And then on Fridays, they have a quiz, and that's all by themselves. And so they get into that routine where the student knows how it's being used. So it can be used in so many different ways that you have to envision, how is it going to help you do what you need to do in your classroom at the time you need to do it. So there's a lot of variables there, but for me, it's initially when they come in, the very first thing is there's always a question on the board, because what that does is it says, all right, learning starts when I get into my seat, and I give them maybe 45 seconds from when the top of the hour goes by. They get 45 seconds to answer that, because that's that first question. And I found that really helps me start. With the quizzes, though, this would be one of those quizzes that I would have on, say, a Friday. They come in, they see this, they have to go through that themselves. So it's really dependent on what you want to do for that day and how you want to get your students to engage. Especially for the people who are using quizzes, this is a very easy way to grade them, because it's all in iClicker, which can be uploaded directly to your LMS or things like that. A couple of other ways that I look at this is this immediate impact for the student. So this one is a little bit more challenging. This is from my calculus-based physics course. But when we look at Gauss's law, you have the charge, and then you draw that Gaussian surface. And we did all those kinds of problems in the class, and what we found is that our calculus-based students weren't as good at the conceptual-based stuff. And so what we did was we asked them questions, these quick clicker questions. And in this case, it's just in our typical stepping through of the Gaussian surface example, where is the first step that this is wrong? And I will let you know that as I watch these things come in, this is really a great example of, I can see where the students are, and I might start helping them, or I might go through what I might do is I might go back and do the exact symmetric example, talking through each of those steps, so that they can come to the realization that the first wrong step is actually B, because the electric field is not perpendicular to the surface, and so you cannot make that assumption that the absolute value of E times the absolute value of the small area can be written like that. Now, C is also wrong because the electric field is not symmetric, and so it's not the same across each of the little DAs, but that's not how this question was asked, but it is a very good learning experience for them to kind of go through and see that. Another quick example is there was, we all kind of look look for different types of ways to teach, and one of them is ranking. There's this ranking tasks in physics that I really enjoyed. And so a couple of things that you can do is you can say, all right, rank the average speed from greatest to least in these examples. And what that does is they're not just answering A, B, C, and D, they're actually thinking through each one separately. So this is a way for us to sort of make the question a little bit richer than just, here's the correct answer. So when I look at that in the upper left, A is really easy. That's constant at 3 divided by 10, so that's 3 meters per second. The B is going to be 0.3, so 3 divided by 10 is 0.3. Well, actually, I made up the units there, didn't I? The next one is that it goes between 0 and 10 over 10 seconds. So the average of that is 5 divided by 10 seconds, or 10. So that'd be 0.5. And then the last one would be, 2 to 5. The average of that is 3.5 divided by 10 to give that. So when we look at the answer here, it's A, C, D, B. So it allows them to actually go through and see a lot of different things. Now I'm going to quickly go over the next slide because I have my decimal places in the wrong place as we go through. Other things that you could actually ask. This was one that I asked, how old are you? Because they can enter in text. And one of the things that it allowed me to actually see that I had some non-traditional students in my class where I had a 26-year-old, I had a 33-year-old. I didn't know that looking out over this, class of 40 students, but asking that question very quickly allowed me to get that feedback. So not a typical, physics question, but it is a way for you to ask certain things about the class that normally you wouldn't want them raising their hands for. And also one other thing to note is that when I started this, I told you the answer to this. And so when you think about how well you retain material, this is a question where, as an instructor, I could have said, well, I told you I started teaching in 2004, so you should have been able to figure that out from there. But since it wasn't important at the time, people aren't going to remember that. So in this case, the answer is D, but you did not, or I did not give you the chance to actually learn that material. I did not help you retain that by saying, I started in 2004. How long? And asking this question immediately. If I had done that, you would have done very well on this question near the end of this presentation. So it's one of those things of using the clickers in order to help them retain some of those really important pieces of information. So creating a question, that's one of the things that iClicker has done very well, is anything that can have a screenshot to it, it can be asked as a question. So whether it's PowerPoint or Word or text programs, in some cases people put up photos and ask those target questions. So it's one of these things where I've even in the middle of lecture just made up questions, put them on the board, and started a quiz. Now, in that case, it's not going to save unless you type it in. But most of the time, I'm not so much worried about the question I've asked. It's the learning that's happening in real time. And so there's a lot of great stuff out there. And one of the things that I want to sort of really push is this idea that you're going beyond the here's a fact with some of the questions to that richer understanding. So things like where is this wrong, or ranking tests, those are applying and analyzing type functions rather than just, what's the capital of Malaysia. And one last thing that I want to talk about is just that there's a new feature within iClicker called Exit Poll. And what you can do as the instructor is at the end of your session, you can end the session with this exit poll. And what happens is the student gets this feedback, which you can see on the right-hand side, which says rate your level of understanding in today's class from low to high, and then it allows them to type some stuff in. Now, you do know who is putting these things in, so you might be able to follow up. But what you can do is get a general sense of how that lecture went and what you might want to start with in the following lecture. I used this a little bit when it came out this semester, and what I was able to do is kind of figure out what question do I ask right at the beginning of the next session, because I knew it was the one that they were confused on, and it allowed me to help them get to the right answer rather than me just saying, hey, a lot of you were confused about acceleration. It's 0 at the top. And as we know, that's not going to help them. So thank you so much for your time. Obviously, I've given you hopefully some great tidbits and examples of what you might be able to do in your classrooms. And at this point, if you have any questions, that would be great.
Yeah, now's a great time. Like I said, feel free to type those into either the chat area or the questions area. We can hang on for a few minutes and give you guys time to put those in. Otherwise, I also understand if you need to drop, that's fine too, but we'll keep this open for a little bit to give you an opportunity to type in any questions or comments.
And also, if you do have other questions, you can always email me. I didn't stick that up. I forgot to. I'm at the University of Wisconsin-Eau Claire. Just type in Matt Evans, University of Wisconsin-Eau Claire, and you will find me, and just shoot me an email and I can help you out. Otherwise, this will be posted, and so if you needed to just kind of remind yourself of a couple of the techniques, you can do that too.
Also, Matt, I'd like to take this opportunity while people might be entering in questions or comments just to say thank you so much for putting this together. We really do appreciate it. I think there's some really great examples here, and hopefully people got a lot out of the presentation. I know that I did, and I want to thank you so much for your time as well. All right, well, I'm not seeing any questions, so that must mean you were very thorough and did an outstanding job, as you always do for us, Matt, so I appreciate that. Again, you guys are welcome to contact Matt, or if there's anything that you need from iClicker, you're also welcome to contact me at rhonda.seelinger@macmillan.com. I can put that in the chat box. And we will be sending a follow-up email with a link to the recording. And so you're welcome to share that, listen to it, whatever. That would be great. And I think on that, I'm not seeing anything. So I want to thank you all for joining us today. And I hope you have a great remainder of your day. And we hope to hear from you soon. And Matt, thanks again. We really appreciate it. I'm going to go ahead and end the webinar.
All right. Thank you so much.
Thank you. Bye-bye, everyone.